Okay, today we're going to look at how humans and natural events can disrupt the cycles that we were just looking at. So we'll start off by looking at how we, as humans or nature, can just simply disrupt the carbon-oxygen cycle, and then we'll look at the nitrogen cycle afterwards. So starting off with the carbon-oxygen cycle, there are certain natural events that will actually disrupt this cycle. These things happen in nature. It'll throw the cycle out of balance. Eventually, the Earth, or the ecosystems, since the Earth and the ecosystems are fairly adaptable, it will adapt and kind of balance everything back out again and eventually reach a new state of equilibrium. But this will cause a disruption in that cycle. So a large forest fire, for example, can be caused by lightning, whatever. That will release large amounts of carbon dioxide into the atmosphere, pull large amounts of oxygen out of the atmosphere. So that would cause a disruption to that cycle. Volcanic eruptions also, even though they're not releasing huge amounts of carbon dioxide, as much as like people do or forest fires do, that's still still has an impact. You can also look at the fact that the ash and the cloud from that volcanic eruption blocks some sunlight, so you don't actually get as much photosynthesis happening, so you're not actually reducing the carbon dioxide that was made, and you're not actually producing as much oxygen. So there's a couple of natural things that affect that. Now, humans obviously have had a pretty large impact on the carbon oxygen cycle. If you've followed anything about global warming, climate change, that kind of thing, or the greenhouse effect, that's caused by human activity. So one of the major things that we've done is we've actually removed a lot of our forests. We've cut down a lot of trees. So we call that deforestation. And by removing those trees, we actually removing a lot less carbon dioxide out of our atmosphere. So now, whether that means we're cutting down trees to make lumber or paper, to build homes, or to make books or whatever, or we're cutting down trees to build cities, or we're deforesting areas to expand our cities or towns or whatever. So by doing that, we've actually reduced these trees that can remove lots of water from the ground, can absorb a lot of the dust in the air, and also provide a ton of oxygen for the population, for people, and also remove a lot of that carbon from the atmosphere. Trees help to remove carbon by storing the carbon in their trunks and their branches. They're absorbing the carbon that we're producing by using our vehicles and things like that. So they're like a really good carbon sink. So that means it pulls in carbon and stores it. And the main reason or main way they do that is through photosynthesis. Now, the other thing that we've done a lot more of in the very recent history of humankind is we've been burning a lot more fossil fuels. We burn gasoline, coal, natural gas to make electricity, to drive our cars, to heat our homes. And we do this more and more all the time. So anytime you are burning something, you have a combustion reaction and you're producing carbon dioxide and water. So if you think about it, if you actually look in like the 1700s, without industry, without vehicles, the carbon dioxide concentration in the atmosphere was about 280 parts per million. In 2007, so fast forward a few hundred years now, with industry, vehicles, with all of the technology we have today, that in 2007 it was up in 380 parts per million. So it went up by 100 parts per million within about 100 years. And even today it's up and well over 400 parts per million. So it's at the time where I got this image from, it was from 2007. Well, that's 14 years ago now. It's increased even more since then, another 30 to 40 parts per million. So that's quite a big increase, and that's because of industry and vehicles and things like that, which leads us to climate change. So the greenhouse effect is just that. If you've ever been in a greenhouse, or even just in a car in the summertime, you get in a car in the summertime before you turn it on, before you turn on the air conditioning, it's a lot hotter inside the car than it is outside, because the car traps that heat from the sun. So the energy from the sun gets through the car's windows, gets into the car, gets absorbed, and is being emitted as infrared, which is what we feel as heat. But that infrared gets trapped inside the car and makes the interior of the car warmer. Well, when we add things like carbon dioxide and water and nitrogen oxides to our atmosphere, these elements are extremely good at absorbing heat. So if you think about burning hydrocarbons, combustion, we're reacting with oxygen and we're making CO2 and H2O. These two molecules are extremely good at absorbing heat. So heat goes into these really well. So anytime we burn stuff, we're putting these two gases into our atmosphere. They're both in the gas state, water vapor and CO2 vapor. CO2 is a gas. Another byproduct, if we're looking at combustion, not burning things perfectly, another byproduct is nitrogen oxides. And they are also very good at absorbing heat. So if you put all of these gases into our atmosphere, that heat that normally hits the earth, just like it hits the stuff inside your car, and eventually radiates back out to space over time, it's like rolling the windows up in your car or putting a blanket on, a heavier blanket on your bed when it's cold out. It's the same idea. It's like we're putting a blanket on the earth, and that heat now, instead of being able to get out to space, gets trapped and it's stuck all in here. So the earth and the atmosphere is getting much, much hotter. So this is why it was initially called global warming and the greenhouse effect, because it's like a greenhouse. However, we started looking at it more as climate change, because a lot of the effects or the impacts on this, the earth as a whole is getting hotter, the atmosphere as a whole is getting hotter, but you're going to see some really weird fluctuations in weather. And so that's why a lot of people, like even my father included, might say things like, oh, it's -40. I thought, what happened to global warming? Well, just because the earth is getting hotter doesn't mean it's never going to get to -40 in the wintertime. It just means that the atmosphere is getting hotter, and that has huge implications on our climate and our weather patterns. So I would encourage you to, I posted a video from Veritasium about these misconceptions. I'd encourage you to watch that video. He kind of goes through all the different misconceptions. Now, the next disruption of a cycle we're going to look at is the nitrogen cycle. So disturbing the nitrogen cycle, if we have too much nitrogen, that also can be a problem. You might think, oh, nitrogen's good, it's fertilizer for crops and things like that. But in the atmosphere, if you get too many nitrates in the atmosphere, you actually get acid rain. If you have too much nitrogen in the water, you get an algae bloom. And on land, it'll actually get back into the water or off gases into the atmosphere. So it'll cause those two things again. So too much nitrogen is actually not a great thing. And nitrogen cycle is mainly disrupted by humans. And here's how we do it. Farmers and golf courses especially, golf courses are really poor for this. Farmers will add tons of fertilizer to their fields in the spring. And if there's any runoff from that, you get a strong rain and it washes that fertilizer off into a stream, river, lake. That's one way it gets put into our water bodies, and you'll end up with these algae blooms that we're going to show you in a minute. Other ways are nitrates and ammonia are put into lots of different things. So in human waste, animal waste, like pig manure, human manure, these wastes contain tons of nitrogen. And so if we don't treat that waste properly, that nitrogen gets into our lakes, rivers, and streams again. So if we're talking about like pig manure, pet and livestock waste, same thing. Actually, for lots of farmers will use that waste as a fertilizer. Lawn and garden fertilizers. So adding extra fertilizer to your grass, eroding your soils, industrial waste, household wastewater. So a lot of our dish detergents and soaps and things have nitrates in them, and also phosphates, which are also not the greatest, but that's not part of this cycle. So most of the nitrogen from those above sources will end up in our water bodies, our aquatic ecosystems. And most of our nitrogen, like if you look at Lake Winnipeg, the amount of nitrogen in Lake Winnipeg, there's studies that have shown that it's increased over 13% in the last 30 years or so. And what that causes is huge algae blooms, or algal blooms as it's said here, and huge weed beds, because algae and weeds are plants, and plants feed off of nitrogen. They use it as a fertilizer. So what ends up happening is you get this algae bloom, and the algae blooms will cause huge, can create toxins. So like things like swimmer's itch and stuff like that. It can harm fish, wildlife. It chokes out the lakes so that the fish can't breathe. It affects drinking water quality, skin irritations. and it just looks bad. So I'm going to show you some pictures of what Lake Winnipeg has looked like. This picture here is actually a shoreline of Lake Winnipeg, and that's algae that's washing up on shore. And you would think, oh, well, algae is a plant. It makes oxygen. That's good for fish. But the problem is this algae blooms, makes lots of oxygen, but then it all dies and it all decomposes. And that decomposition actually steals all the oxygen out of the lake. And basically the fish and other organisms in the lake are suffocating. So there's a video that I've posted in the lesson that you can watch on your own time. It's not very long. It's maybe 10 or 12 minutes or something. And it actually walks through and shows you Lake Winnipeg. It's the largest freshwater lake in the world, and it's in trouble. So this is in June 28th of 2010. You don't really see a lot of algae, a little bit of green stuff here. And this is another satellite image in July. So 1 month later, and you can see how much green. So this is that bloom that you get. So you get lots of nitrogen, you get an algae bloom, and that when it blooms, just like when a flower blooms, it lasts for a little while, but then it kind of dies off. And when that algae dies off, that's what creates a huge problem. So eventually that crash happens, and that decomposing weeds and algae will remove the oxygen from the water. You get a huge uptake in bacteria, and basically will start killing fish because of a lack of oxygen. Now, where does a lot of this come from? Well, a lot of it does come from farm runoff. So nitrates and ammonia running off from farmland where we've fertilized. Golf courses are also a bad they get kind of a lot of the blame for this too, because they apply tons of fertilizers. Even just humans putting fertilizers on their lawns and things. It's always, even in the city, it's going to end up in a river somewhere. It's going to run off onto the street. The street flows into the sewer, and the sewer flows into the river, and the river flows into Lake Winnipeg. The other thing we got to remember is Lake Winnipeg also has a huge watershed. So we're getting all of this from a large area, and I'll show you what that looks like in a second. Wastewater, human sewage collects and also causes nitrates levels to rise as well. Lots of homes are connected to septic fields and things like that. So we try to break down this water, these nitrates, before it gets to the lake. But sometimes if you have problems with it, or if you don't have people maintaining their septic fields properly, that adds nitrates to the lakes, rivers, and streams. Now, this is what I really wanted to show you. This is not just a local thing. So this whole area, from all the way from Banff to Thunder Bay, down into almost South Dakota and up north of Flin Flon, this whole area all flows into Lake Winnipeg, which is right here. So my hometown is Fort Frances. Sisters in Ontario over here. All the water in my area, Lake of the Woods, Rainy Lake, this area down here, that water actually flows up into Lake Winnipeg. Even as far as Banff, all that water eventually flows through all this river system over to Lake Winnipeg. So, and we get, like, even from North Dakota, we get a lot of our water from North Dakota. So this huge area is what's dumping into Lake Winnipeg and then eventually off into Hudson's Bay. So this is not just a local problem. We can reduce our use of fertilizers and things like that. We can treat our water better here, but it might not actually, it'll have an impact, but we also need to get our neighbors to help out as well. So it's not just a local problem.